video, it had that toggle switch back and forth of multiplying by -1. Then it showed what would it be if you had the imaginary system and it was a 4 toggle switch. It just kept going in a circle. You guys remember that in the video? This is going to show why that is. So once you get the pattern down, you'll see what happens as you move throughout your powers. So I to the first, we know that I is the same thing as square root of -1, which then moves us into the imaginary system. So if I is just the square root of -1, we're going to go back to I. So it stays imaginary, essentially. This is in your notes on section 4. Yeah. If I do I squared, so I'm going to take this square root of -1, and I'm going to square it. Well, what happens to a square root and an exponent of 2? What do they do to each other? Cancel each other out, right? So what would we have left? -1, right? So if you remember that toggle switch, it moves back and forth between the real system, imaginary, real, imaginary, real, imaginary. So I squared is in the real number system because it's -1. It has an actual value. Now we're going to do I cubes. So we're going to break I cubed into I squared times I. To show this part, I squared times I. Well, what is I squared? What did we just decide I squared is? -1, right? So we're going to say that that equals -1 times I.
Oh, it'd be
So we have a
or would it be +1 I or would it be -1 I?
-1 I is what it is. You were right first time, I think. So we have this -I. So that would be at the bottom part. Remember that toggle that went around? You have the -I down below. Yeah, it's just kind of breaking them down. Now we have I to the 4th. I to the 4th, I could rewrite this as I squared. That would be I to the 4th based on the properties of exponent. Well, what is I squared? -1. So it's -1 squared. Positive. I had to think as I was talking, sorry. Okay, so we went imaginary, real. And that's the pattern of that toggle switch as it went around the real and the imaginary. I, -1, I, 1. Alright, so let's do this again. So first, everybody understand that part. What I did there. Broke down the I squares and... Do you understand how I got I cubed as I squared times I?
Would that just be because if you add that I squared or whatever, it'd be 3?
Yes.
Oh,
Yep.
yeah.
And really what I was trying to do is relate everything to I squared, because I know what I squared equals. What can I make I to the 5th? How can I break that down? There's a couple ways we can do it.
You do I squared times I.
We could, but then we'd have to break it down further. If we went back first, we could break it down to I to the 4th, right? So what is I to the 4th equal? 1. So if I say it's I to the 4th times I to the 4th, we already said equals 1. So what do we back to?
-1.
This is 1 times I.
Oh, 1 I.
Yep. I. So see how they line up like that? You could say I squared times I if you wanted to keep going back to I squared. But we already know what I to the 4th equals, so that's why we kind of go back to 1 to the 4th. I to the 6th, what could I break that one down to? What would be one that would make sense?
So
I squared and I cubed. That would give... Yeah, and then we'd have -I times -I. And almost. We'd have I cubed, so it'd be -I times -I would give you a positive I squared. And we know I squared equals -1, yeah. You could get to it from that. What were you going to say?
I just got really confused just now, but
Let's say you can walk through it with Kayla.
yeah, it's just like brain farted me. But like, could you go I4 to the 4th times I squared? Is that what you guys were saying?
That's what I was going to do. She said what she did was absolutely right. She did I cubed times I cubed because they would be I to the 6th, right? Well, we already know I cubed is negative I, so you should have negative I times negative I. Well, negative times a negative is a positive, and I times I would be squared. Then I squared equals negative 1. That's one way to do it. Absolutely right. Or what you said, I to the 4th times I squared. What's I to the 4th equal? 1. And then what's I squared equal?
Negative 1.
So our final answer would be? Both paths will get you there. It's whatever you pick in your head is fine.
Okay, I'll do this stuff.
I honestly don't know who the father of imaginary numbers were.
Sometimes I just sit here and watching like all this and everything, and, like learning about it. It's just like it just makes me really wonder how this will come up.
I to the 7th. What do you want to break I to the 7th into?
3 and 4.
I like it. So if we do I to the 4th, we already know what I to the 4th equals, right? I'm going to write I to the 4th first. What's I to the 4th? 1. I cubed. I'm going to put negative I, the same thing. And then 1 times negative I would be negative I. See how they're lining them up? There's that toggle switch around the system. How about I to the 8th? What do you want to do? I would do that. Yeah, I to the 4th times I to the 4th. Well, I to the 4th is equal to so 1 times 1 is, and this says I to the 4th. It almost looks like I to the negative 4th, but that's my dot to my I. All right, you guys want to do another row? We could do I to the 9th, I to the 10th. What's that?
It's a pattern.
It is a pattern, exactly. Does everybody see the pattern?
There's I in the negative 1, and then negative I and 1. Oh, okay, so it's I, negative 1, negative I. So it's
Yep. So if I ask for I to the 9th, I to the 10th, I to the 11th, I to the 12th, you would know right away what it is. What's I to the 9th? I was I to the 10th, I to the 11th, I to the 12th. And it's just every 4th it repeats. And that was that toggle switch going around in the video.
I don't even know how high.
I know, that's good.
I'm ready.
So if I wanted I to the 15th, how could I do that one? A couple ways we could do it. Negative I, exactly, following the pattern, right? Because then you would do, if you wanted to follow it that way, you would have 13, 14, 15, so negative I. That's one way to do it. Mathematically, another way is to break it down. So how could I get 15 and break it down into these different components? And I think this gets a little bit trickier. I like the pattern. If you can keep track of it, you just do multiples of 4, right? Where you're at in the multiples of 4. Does that make sense?
Yeah.
So one way we could do
We do 7 and 5.
I to the 7 and 5.
No, because so it'd be like what 7 is 14, 7 and 8.
Yeah, 7 and 8, right?
Yeah.
So if I did I to the 8th times I to the 7th, and I already know what each of those equal. What is I to the 8th? 1. I to the negative 7th is negative I, which would give you negative I. So there's a mathematical way to do it. And then there's the pattern. What about 62? What am I going to do there? When you get something like 62, it's even, right? So you could count. Addie's not wrong. What if I based it on I squared? Well, if I had I squared, what would I have to take this to get 62? Thinking about your powers of exponents.
What?
31, yes. Remember the powers of exponents that we did at first? 2 times 31 gives me 62. What is I squared? An odd number to a, a negative number to an odd exponent will always be Negative, right? Let's say negative. Lots of ways to do it. There's many. Ethan? You would have to think about division and remainders. Like if I know something's divisible by 4, then it's always going to be a 1. If I did something, let's do it. Oh, let's see. Yeah, okay. Alright, so number 15, where we're going to use this, when we have a number like 4i times 7i, it has a real component and an imaginary component to it. Meaning 4 is real, I is imaginary. So if I first take my real numbers, 4 times 7, what would I get there? That's okay. 7 times 4. What's 7 times 4? 28.
So what would be 28i squared?
Good. So we need to know, well, what is I squared? What did we just say I squared is? Negative 1. So when that happens, you're really doing 28 times negative 1. Yep. And now that number that had a mix of real and imaginary now became completely real. Real number system. Does that make sense? Okay. Let's try it again with number 16. First, multiply all of your real numbers together. So negative 4 times 2 times negative 9. Positive 72, right? And then I times I times I. The negatives were already taken care of. I cubed. Is that, or you jumped ahead of me?
Yeah.
Anna was right. She just jumped ahead of me. My apologies. Well, what is I cubed? Negative I. So now, if this is I cubed, we have negative 72i. So we want to simplify it as much as possible. So negative 72i. This part will seem a little more clear. You're not going to have a ton of I to the 80th. All right, let's try number 17. Now we have to think. Here, go ahead.
Would you do 2 cubes times 5? Or
Yes, you cube it first. Is that what you're asking?
yeah.
100%. So we need to follow our PEMDAS, parentheses, exponents, then multiplication and division. So 2 cubed. What is 2 cubed? Very good. And then we have I cubed times 5i. So I first handled my exponents, distributed them. What is 8 times 5? What did you say? 40. I thought you said something different. I'm sorry. 4. Then we have I cubed times I, which would be? Very good. I to the 4th. What is I to the 4th? 1. So what's my final answer?
How do you get 8?
We have to handle this exponent first, so 2 cubed is 8.
Oh, okay.
So again, we went from a mix of imaginary and real, and then it ended just on the real.
So, since you multiplied that cube to the 2, it would carry over, and then where's that 4?
I cubed times I divided by 4. 8 times 5 gave us 40.
So, and then your answer would just be, you don't have to do anything after that point. You can just keep 40 there, just knock off the I and the 4.
Say that again.
So, because you did 40.
We have the I squared of 3, we're going to square that. We also have negative 8i all squared. We're going to handle the exponents first. So the first set of exponents, let's say I squared of 3 squared. What would I get there? I heard 3i. Close?
Yeah.
And then what about the I? Don't forget to square the I. Yeah, because square root of 3 squared gives us 3. I squared. Yeah, I squared. And then negative 8i, and then square it up, so it's negative 8 squared.
So you're not actually like squaring anything, right? Why didn't we square 3?
Because it's the square root of 3.
Oh.
Anything squared. And then we have I squared over here as well. Everybody know where I got everything? And again, those dotted i's are not negative. So now we have to multiply the reals. What's 3 times 64? 190. Very good. And what's my exponent to my I?
4.
Very good. 190. 192I to the fourth. We're not done yet. What is I to the fourth? 1, very good. So 192 times 1, which is obviously 190.
Oh, wait, okay, so when you scroll up,